Is your refrigerator still not cooling after checking the basic things? Maybe the condenser coils are clean, the fans appear to be working, the door gasket looks fine, and the compressor is running, but the refrigerator is still too warm. If that's the situation you're dealing with, don't start replacing expensive parts yet. In Part 1, we covered 7 important checks, including refrigerator temperature, the evaporator fan, condenser fan, dirty condenser coils, the door gasket, compressor operation, and the evaporator frost pattern. In Part 2, we're going deeper. Today, we're going to look at 7 more tests that can help you find the real cause of a refrigerator that isn't cooling properly. We'll check the defrost system, examine the evaporator coil, test the temperature sensor, look at the compressor start components, identify compressor symptoms, discuss signs of refrigerant or sealed system problems, and finally put all the symptoms together to determine what is most likely wrong. Let's get started. Number 1, check the defrost system. One of the most common reasons a refrigerator can stop cooling properly is a problem with the automatic defrost system. Modern refrigerators continuously produce frost on the evaporator coil during normal operation. That's normal. The problem happens when the refrigerator cannot remove that frost. Normally, the refrigerator periodically enters a defrost cycle. During this cycle, the cooling system stops and a defrost heater melts the accumulated ice. The melted water then drains away. If the defrost system fails, ice can gradually build up on the evaporator coil. Eventually, that ice can block airflow. The freezer may still feel cold, but the refrigerator compartment can become warm. So how can you recognize this problem? Open the freezer and look for excessive frost or a thick layer of ice around the rear evaporator cover. If you see heavy ice buildup, don't immediately assume the refrigerator simply needs to be defrosted. Manually removing the ice may temporarily restore airflow, but if the defrost system is still faulty, the ice will come back. Possible causes can include a failed defrost heater, a defective defrost sensor or thermostat, wiring problems, or control board issue. Testing electrical components inside a refrigerator requires proper knowledge and safety precautions. Always disconnect power before accessing internal electrical components. If you're not trained to perform these tests, this is a good point to call a qualified appliance technician. Now let's look at the evaporator coil itself, because its frost pattern can give us another important clue. Number 2, examine the evaporator coil frost pattern. The evaporator coil is one of the most useful areas to inspect when diagnosing a refrigerator cooling problem. The coil should normally develop an appropriate frost pattern when the refrigeration system is operating correctly. But the pattern can tell us whether the problem may be related to defrost, airflow, or the sealed refrigeration system. For example, if the entire evaporator is covered with a heavy layer of ice, airflow may be restricted because of a defrost problem. If the evaporator has a relatively even frost pattern, but the refrigerator is still warm, the problem may be related to airflow, fans, dampers, or temperature control. But what if only a small portion of the evaporator coil has frost while the rest remains completely clear? That can be a warning sign of a refrigeration system problem. Possible causes can include low refrigerant charge, a restriction in the sealed system, or a problem with refrigerant circulation. However, frost patterns are not an exact diagnostic test by themselves. Different refrigerator designs use different evaporator configurations. Temperature, operating time, airflow, and the refrigerator's current operating condition can also affect the appearance of the frost. So use the frost pattern as a clue, not as the only evidence. And never puncture or bend the evaporator tubing. A damaged sealed system can turn a simple refrigerator problem into a much more expensive repair. Now, let's check one of the components that tells a refrigerator how cold it actually is. Number 3, check the thermistor or temperature sensor. Your refrigerator needs to know the temperature inside the cabinet. That's where thermistors and other temperature sensors come in. A thermistor is an electronic temperature sensor that changes its electrical resistance depending on temperature. The refrigerator's control system uses this information to decide when to run the compressor, fans, and other components. If the sensor gives incorrect information, the refrigerator may behave strangely. For example, the compressor might run too long. It might not run long enough. The evaporator fan may operate incorrectly. Or the refrigerator may appear to reach the selected temperature, even though the actual temperature is much warmer. The exact sensor location depends on the refrigerator model. Some refrigerators have sensors in the refrigerator compartment, freezer compartment, evaporator area, or other locations. Before replacing a sensor, check the refrigerator service information for the correct resistance values at specific temperatures. A multimeter can sometimes be used to measure the thermistor's resistance, but the expected resistance varies by manufacturer and model. There is no single resistance value that works for every refrigerator. So don't replace a thermistor just because the number looks unfamiliar. Use the manufacturer's specifications whenever possible. Also inspect the sensor wiring and connector. A loose connector, damaged wire, or corrosion can create symptoms similar to a bad sensor. This is an important point because replacing a good sensor won't fix a wiring problem. Now, let's move to the compressor starting system. Number 4, check the start relay and overload. The compressor needs help getting started. That's where components, such as the start relay and overload protector, come into play. The start relay helps provide the appropriate starting circuit for compressor. The overload protector helps protect the compressor if it draws excessive current or becomes too hot. If the start relay fails, the compressor may not start properly. You may hear a click followed by silence. Then, after a short period, you may hear another click. This can repeat over and over. Another symptom can be a compressor that tries to start, hums for a few seconds, and then shuts off. The overload protector may trip because the compressor is drawing too much current or because the compressor is having difficulty starting. However, don't automatically assume the start relay is bad. A failing compressor can produce similar symptoms. Electrical testing around a refrigerator compressor can be dangerous. Always disconnect power before removing or inspecting electrical components, and follow the manufacturer's service procedure. If you don't have experience working with compressor electrical systems, professional diagnosis is the safer option. Now, let's talk about the compressor itself. Number 5, look for compressor symptoms. The compressor is one of the most important components in the refrigerator. It's responsible for circulating refrigerant through the sealed system. When the compressor is operating normally, you will usually hear a low humming sound and feel some vibration. But there are several symptoms that can indicate a compressor-related problem. One possibility is that the compressor doesn't start at all. Another is that it repeatedly starts and shuts off. A compressor can also run continuously while the refrigerator remains warm. This doesn't automatically mean the compressor is bad. The compressor may be running continuously because another problem is preventing the refrigerator from reaching the correct temperature. For example, a defrost problem can block airflow. A dirty condenser can reduce heat transfer. A fan problem can cause overheating. A sealed system problem can also cause long compressor run times. So don't diagnose a bad compressor based on one symptom. Look at the entire system. Is the compressor running? Are the fans operating? Is the condenser clean? Is the evaporator covered in ice? What does the frost pattern look like? What is the actual temperature inside the refrigerator? Combining these clues is much more useful than replacing parts based on sound alone. And now we're getting close to one of the more serious possibilities. Number 6, look for signs of a refrigerant or sealed system problem. If the fans are working, the condenser is clean, the defrost system appears normal, and the compressor is running, but the refrigerator still doesn't cool properly, we need to consider the sealed refrigeration system. A sealed system contains refrigerant that circulates through compressor, condenser, expansion device, and evaporator. If there's a refrigerant leak, a restriction, or another sealed system problem, cooling performance can drop significantly. One possible clue is an unusual evaporator frost pattern. Instead of seeing a normal frost pattern across the evaporator, you may see frost concentrated in only one small area. Another clue can be a compressor that runs for very long periods without bringing the refrigerator down to the correct temperature. However, these symptoms do not prove that the refrigerator is low on refrigerant. Refrigerators are sealed systems. Refrigerant doesn't normally get used up like fuel. If the refrigerant charge is low, there may be a leak or another problem that needs to be located and repaired. Adding refrigerant without finding the cause is not a proper repair. Sealed system work also requires specialized tools, correct refrigerant handling, leak testing, and knowledge of the specific refrigerator. For that reason, this type of repair should be performed by a qualified refrigeration technician. So now let's put all of these clues together. Number 7, final diagnosis: fan, defrost, compressor, or sealed system. This is where troubleshooting becomes much easier. Instead of asking, which part should I replace? Ask, what symptoms is the refrigerator giving me? Let's start with a fan problem. If the evaporator fan isn't running or airflow is weak, you may have a fan motor, wiring control, or ice blockage problem. If the freezer is cold but the refrigerator compartment is warm, airflow becomes especially important. Next, consider a defrost problem. If the evaporator is buried under thick ice or snow, the defrost system should be investigated. Remember, simply melting the ice may only provide a temporary solution. Next, consider the compressor and start components. If the compressor repeatedly clicks, hums, and shuts off, the start relay, overload, power supply, or compressor itself may need further testing. If the compressor doesn't run at all, electrical and control issues need to be investigated before replacing the compressor. Finally, consider the sealed system. If the compressor is running, the fans are operating, the condenser is clean, there is no major ice blockage, and the evaporator shows an abnormal partial frost pattern, a sealed system problem becomes more likely. That could involve a refrigerant leak, restriction, or another refrigeration system issue. Again, this is a diagnosis based on symptoms, not a guarantee. Professional testing is required before replacing expensive components. Here's one of the biggest mistakes people make when repairing refrigerators. They replace parts before identifying the actual problem. They replace the fan, then the thermostat, then the sensor, then the start relay, and eventually they discover the original problem was something completely different. Good troubleshooting works in the opposite direction. First, collect the symptoms. Then test the simplest possibilities. Check temperature, check airflow, check fans, check the condenser, check the door seal, check frost buildup, check compressor operation, then move toward more advanced diagnosis. This approach can save you time, money, and unnecessary parts replacement. Let's quickly review the 7 tests from Part 2. Number 1, check the automatic defrost system and look for excessive ice buildup. Number 2, examine the evaporator frost pattern for clues. Number 3, check the thermistor or temperature sensor according to the manufacturer's specifications. Number 4, investigate the compressor start relay and overload symptoms. Number 5, observe compressor operation and look for unusual starting or running behavior. Number 6, look for signs that may indicate a refrigerant leak, restriction, or other sealed system problem. And number 7, combine all the symptoms to determine whether the problem is most likely related to airflow, defrost, the compressor, or the sealed refrigeration system. Remember, refrigerator repair isn't about guessing which part to replace. It's about understanding the symptoms and testing the system step by step. And if the diagnosis points toward electrical high voltage components or sealed refrigeration work, don't take unnecessary risks. Call a qualified technician. If this 2-part refrigerator troubleshooting series helped you, hit the like button, subscribe to Easy Solutions, and turn on notifications for more practical appliance repair and troubleshooting videos. Thanks for watching. Stay safe, troubleshoot carefully, and I'll see you in the next Easy Solutions video.